Section 11.4, we're going to move on to volumes. We're going to look at volumes of prisms and cylinders. So the volume is the space that a figure occupies, and volume is always measured in cubic units. The first theorem we're going to look at is Cavalier's principle. He says that if two space figures have the same height and the same cross-sectional area at every level, then they have the same volume. So if this prism, which is a square prism, and this prism, which is also a square prism, but you can see that it's been slanted, and if this circular prism or cylinder has the same area, if capital B, the area of the cross-section, is equal on all three of these, and if their heights are the same, then their volumes are the same. Doesn't matter whether they're tipped, whether their shape is different, as long as the area of the base is the same and the height is the same, they have the same volume. We'll get back to that later. So volume of a prism. The volume of a prism is the product of the area of the base. We always use a capital B for area of a base and the height of the prism. So volume equals base, area of the base, times the height. So think of it this way. If we have a triangular prism, and the triangle has a certain area, and I stack those triangles up until we have a certain height. So I'm stacking up a bunch of triangles on top of each other. If I take the area of one triangle and multiply it by the height, I have the volume of the entire prism. So let's find the volume of this prism. Now this one's laid on its side, but this is going to be my base. This will be my height. So the area of the base, and let me use a capital B instead of a capital A. That would make more sense for our formula. The area of the base is 1/2 the base times the height of the triangle. Notice this small b represents this base of the triangle, whereas the capital B represents the base of the entire prism. So 1/2 base times the height is 12, and that should be square units because we're talking about just a flat surface right now. The area of the entire prism is that capital base, the base of the area, times the entire height of the prism, and that would be 12 times 12, or 144, and now we have centimeters cubed. So the area of the base times the height of the prism gives you the gives you the volume of the prism. Volume of a cylinder. It's the product of the area of the base, again, our capital B, and the height of the cylinder. So the volume of a cylinder is the area of the base times the height. Since the base is a circle, we can call that pi r squared. Let's do one of these. So the area of the circular base is pi r squared, and we're going to multiply that times the height of the prism to get my full area. So pi r squared times the height would be 81 pi, and that's going to be inches cubed. Again, one area of a base, stacking it up, adding it up, multiplying it by how many I get for my height to fill up the entire cylinder and get the volume of the cylinder. So let's go back to our Cavalier's, can't say that one, principle, which is that if I have an area, this is a stack of CDs, even if I make them crooked, the volume of these two is the same. If I have the same height, the same number of CDs, doesn't matter how I stack them. I could even stack them so that they go all wonky like this, right? As long as I have the same height, and as long as at each level the area of the cross section is the same, then my volume is identical. So looking over here, the area of the base times the height. The height that we want is the height of the stack, not the slant height, because the slant height in these two will change, but the volume does not. The height of the stack is what I'm looking for. So the first thing I have to do is find this height. Well, I have a right triangle. We could use Pythagorean, but I've noticed that this is a multiple of 3 and this is a multiple of 5. So using my 3, 4, 5 right triangle, since I've got 9 and 15, this side would have to be 12. They are multiples of 3. So that's my height. The area of my base is pi r squared. The radius is 4. The height is 12. So that's going to be pi times 16 times 12, which is 192 pi. And that's it for this section. It's a pretty cut and dry volume. The area of the base, whatever it is, times the height. Doesn't matter what our base looks like. If the base looks like this and I can find the area, and then I can take the height of it, if I can build that up into a pyramid, can't draw it, but you know what I'm talking about, we can